In this example, I'm going to introduce what in math is called factoring. Let's start with the following example. We'll need to take 2x squared and multiply that by the expression 3x plus 5. So we're taking monomial and multiplying it by the binomial, right? What's the way of multiplying those two? Well, we have to use the distributive property, right? We have to take 2x squared and multiply by 3x, and then we have to take 2x squared and multiply that by 5, right? Let's try that. Now, 2x squared times 3x. 2 times 3 gives us 6, and then x squared times x. Remember, we have to add powers, so that's going to be x to the third power. And then the second product is 2x squared times 5. 2 times 5 is 10. And then I just have to rewrite x squared. I don't have anything to multiply it by in the second product. Okay, so what we just did, we multiplied, right? So I went in this direction. That's what I had, product. And I multiplied and I got this result. So multiplication going this way. But factoring is the reversed process. So in other words, when we factor, we start with expression of this kind and we go backwards. In other words, our goal, so factoring, going the other way, our goal is to take the given expression and rewrite it as the product of two other expressions. So we start with an expression like that and we write it as the product of, in this case it would be monomial and binomial, right? It's called factoring because we rewrite it as the product of two factors. So the question is, how do we do that? Well, for that we need to know the following. This monomial that we have here, this term, is a special one, and it's actually the GCF of those two terms within the original expression. So I am claiming that 2x squared is the GCF, the greatest common factor for 6x cubed and 10x squared. Let's check that. So remember, when we have to find the GCF for two or more expressions, first let's focus on the numbers. So we have 6 and 10. So GCF is going to have the numerical part if we can find the largest number that divides 6 and 10. Well, the largest number that divides 6 and 10 is 2, right? And well, here it is, that's 2. But then we have to focus on the variables. I have x cubed and x squared. So what's the GCF when we work with the variables? Well, the GCF is going to be that variable raised to the smallest power among the present ones. And if I look at those two powers, then the smallest one is actually power 2. Well, and that's why here we have x to the second power. So that's the GCF. But then how do we obtain the other expression? Well, let's see an example and it will help us to understand the entire process. Let's do an example where we're going to be asked to factor. Let's try. So factor. We're going to look at a few. So the first one is 20x to the third power plus 24x to the fifth power. Okay, and that's it. Two terms. So see how it's similar to what we have here on the right hand side? This kind of format, just a number of terms. Remember, it's called polynomial, this kind of expression. So our goal is going to be written in this form. Well, and then the first step will be to find the GCF. We're going to find the GCF and we're going to write it over here. So we'll have to put the GCF over here. Now, what's the GCF? When we look at the numbers 20 and 24, we need to find the largest number that divides 20 and 24. So I think that's 4. I think 4 is the largest number that divides both of them. But remember, we can double check. There's a way to make sure that we got the right GCF. And that method is called prime factorization. So we're going to split 20 and 24 into prime factors. For that, we're going to start splitting each number any way we can. So 20 I can split as 2 times 10. Now 2 is prime, I'm going to circle it, and then 10 I can split as 2 and 5. Both are primes, I'm circling them. So 20 consists of 2, 2, and 5. If I multiply those out, I'm going to get 20. How about 24? 24 I can split as 4 times 6. 4 is 2 times 2. These are primes, and then 6 is 2 times 3. They're also primes, which means that 24 consists of 2, 2, 2, and 3. This is prime factorization of 24. And to find the GCF or confirm that it's 4, we'll have to find common prime factors in these two numbers. In other words, I have to find the pairs. Here is one pair, so GCF will have 2 since it's common for both numbers. And I have another pair, so it means that GCF will have another 2 because it's also common for both numbers, or it's the same in both numbers. And that's all, right? I don't have anything else in common. No other pairs here. So it means that it's 2 times 2, which is 4. Okay, so that confirms our initial guess, 4. So that's just for the numbers, right? The GCF, numerical part of the GCF. But then we're going to switch to the variables. It's x cubed and x to the 5th power. Now with variables, things a little bit easier because if that same variable is present in each term, we're going to have that variable, but the power that we'll have to use is the lowest power among the present ones. So I have third power, cube, and the 5th power. The lowest is 3. So I have to use the lowest power here. That's the GCF. And now I have to obtain, so if we go back to our first example, we just obtained the GCF. So now our goal will be to end up with this kind of expression. Now, what is that expression? I can think this way. I can kind of think backwards. I can ask myself, by what I have to multiply 4x cubed? So I'm pretending that I'm distributing 4x cubed. By what do I need to multiply 4x cubed so that I go back to the original term, so I get my original first term? So 4x cubed times what gives me 20x cubed? Well, I'll do one thing at a time. So first, I'll think about the numbers. 4 times what gives me 20? Well, that must be 5, right? 4 times 5 gives me 20. Now, x cubed times what gives me x cubed? Well, actually, x cubed doesn't have to be multiplied by anything here because I need to get x cubed, right? So that means that I'm only going to have 5. But now as I continue, so plus, now I have to obtain the second term. And I will repeat the process. 4 times what? Right here. Gives me 24. Well, it has to be 4 times 6. Okay, and then, so 4 times 6 is 24. And now the variable x cubed times what? So what do I need to write here? So that I get, as a result, x to the 5th power. Well, x cubed has to be multiplied by x to what power? So that together I'll get x to the 5th power. Since powers have to be added, it has to be the second power. X cubed times x squared. So in other words, I am applying the distributive property without knowing by what I'm multiplying. I have to create those terms here. So 4x cubed times 6x squared gives me 24x to the 5th power. And by doing that, now I obtain the expression inside the parentheses. By the way, that expression is always going to have same number of terms as my original expression. So if I have 2 terms here, then I will have 2 terms in this expression. And that's the answer for factoring question. So we started with this expression and we were able to factor it, rewrite it as the product of 4x cubed and this binomial. So that's what it means to factor. So I have a product in between them. So I can put a dot. Let's try it one more time. Let's do one more example. Let's try this example. 9a to the 7th power minus 12a to the 5th power plus 18a to the 3rd power. So we start by thinking about the GCF, or getting the GCF. By the way, you don't have to really write it. That's just me making notes for myself and for everyone. So what's the GCF? here we have three terms, 1, 2, 3. So we notice that all terms have numbers. Let's see if we can find number that divides all of them. And our goal will be to find the largest one. So if we have 9, 12, and 18, then what number divides all of them? I think that's 3. And in fact, 3 is the largest one. Well, 3 is the only one, and that's why it's the largest one. So it's 3. Now let's look at the variables. It's a to the 7th power, a to the 5th, a to the 3rd. So when we work with variables, we have to find variable with the lowest power. 7, 5, 3, the lowest power is 3. That's the GCF. Once you find the GCF, then you're gonna open the parentheses, and here your goal will be to end up with the same number of terms as the original expression. So I will have to have 3 terms over here. But what those terms are? Well, I can get them if I think in terms of the distributive property. So by what do I need to multiply 3a cubed right here to give me the first term, 9a to the 7th power? Make sure you think about number first and then variable. So 3 times what gives me 9? Well, it's 3 times 3. So I have to have 3 here. 3 times 3 gives me 9. But then a cubed times what times a to what power gives me a to the 7th power. Since powers have to be added, I'll have to put 4, power 4. 3 plus 4 is 7, right? So a cubed times a to the 4th power will give me the first original term. Next I'm trying to obtain the second term. So I'm asking myself, by what do I need to multiply 3 so that I get negative 12? Well, it's 3 times negative 4, so I'm going to put minus 4. And then a cubed times what gives me a to the 5th power? Well, it has to be a to the 2nd power. 3 plus 2 is power 5. So if I multiply those two terms, I'll go back to the second term. And then finally, the last term. 3 times what number gives me positive 18? Must be 6, right? Plus 6. And then what else I have here? I need to obtain a cubed, and I already have a cubed. So it means that I don't need to multiply it by anything over here. It's just enough to multiply 3a cubed by 6 to get 18a cubed. So that means that I'm not going to have anything else there. So it's plus 6. I'm going to move the parentheses. Well, and that's going to be the answer. That's this trinomial written in the factored form. So it's the product of 3a cubed and another trinomial. So that's what it means to factor that expression. Let's try one more example. So this time we have 7x cubed minus 3x squared. Remember, we start by determining the GCF. What do those two terms have in common? Well, they both have numbers. Let's see if we're going to find the largest number that divides those two. So I have 7 and 3. Can I find a number that divides 7 and 3? No, right? 7 and 3 are primes, but that's actually not the only reason, but it's just they don't have anything in common, right? There's nothing that divides both of them. So it means that GCF here is not going to have numerical part. But how about variables? We have variables for both terms, x to the 3rd power, x squared. So what's going to be the GCF? It's going to be x raised to the lowest power. So that's power 2. So that's the GCF. That's the GCF. And now I'm going to set up the parentheses. And inside the parentheses, I know that I'm going to have as many terms as my original expression. So I will have 2 terms. But what those terms are, I'm thinking this way. I have to take x squared and multiply by something so that I get 7x cubed. Well, I have to have 7 there, right? So that I get 7 as a result. And then I have to have another x, because x squared times x is going to give me x cubed. Next, x squared times what gives me negative 3x squared? Well, I have to create negative 3, so it means that I need to multiply by negative 3. But since power of x has to stay as within the GCF, right? I have x squared, I'm multiplying here, and I need to get x squared. So it means that power does not have to be adjusted. So in other words, I'm not going to have anything else there, just minus 3. So I'm going to move the parentheses. And that's going to be the answer in the factored form. X squared times 7x minus 3. So that's how we factor this expression. And the last example is this. Let's do 10a plus 20. We're kind of going from the harder examples to easier examples, but that's okay. So 10a plus 20. Now the reason I want to use this example here is because we need to be careful when we find the GCF. So when we try to find the GCF to place over here, first we'll look at the numbers. The numbers, each term has a number. It's 10 and 20, right? What's going to be the largest number that divides 10 and 20? Well, it's going to be 10, right? 10 is the largest number that divides both of them. But then, is the GCF going to have a variable part? What do you think? Well, actually, it's not going to have variable part, because if you look at the terms, only one term has variable, and the second term does not have a variable. Remember, GCF, it's something that all terms have in common. But obviously, variable, it's not something that I have in common. Only one of them has variable. So that means that GCF is only going to be 10. It's not going to have the variable part. Now I'm going to open parentheses and write down the remaining expressions. So that expression I can obtain by thinking, by what do I need to multiply 10 over here to get 10a? Well, it has to be a, right? 10 times a gives me 10a. And then by what do I need to multiply 10 over here so that I get 20? Well, it must be 2 plus 2. And I also confirm that number of terms inside the parentheses here is the same as the number of terms in my original expression.